Hello explorers and welcome to another video. Today we are going to do day 13 of Advent of Code. So let's see here. 13 was just released, so what does it entail? Day 13, transparent origami. You reach another volcanically active part of the cave. It would be nice if you could do some kind of thermal imaging so you could tell ahead of time which caves are too hot to safely enter. Unfortunately, the submarine seems to be equipped with a thermal camera. When you activate it, you are greeted with congratulations on your purchase. To activate this infrared thermal imaging camera system, please enter the code found on page 1 of the manual. Apparently, the elves have never used this feature. To your surprise, you manage to find the manual. As you go to open it, the page 1 falls out and it's a large sheet of transparent paper. The transparent paper is marked with random dots, includes instructions on how to fold it up your puzzle input. For example, the first section of this list is dots on transparent paper, represents the top left coordinate. The first value x increases to the right and the second value y increases downward. So you have the coordinates 3, 0 is to the right of 0, 0, and coordinates 7, 0, 7 is below 0, 0. Yeah, so it's just a grid. The coordinates in this example form the following pattern where hash sign is a dot on the paper and it's an empty position. There is a list of fold instructions. Each instruction indicates a line in the transparent paper and wants you to fold the paper up for horizontal lines or left for vertical lines. In this example, the first fold instruction is along Y7, which designates the line formed by all the positions where Y is 7, marked here with dash. Yeah, okay. So we had 2 above and 2 below. So that was the folding point, okay? Because this is a horizontal line, fold the bottom half up. Some of the dots might end up overlapping after the fold is complete, but dots will never appear exactly on the fold line. The result of doing this fold looks like this. Now only 17 dots are visible. Notice, for example, that the 2 dots in the bottom left corner before the transparent paper was folded, after this fold is complete, those dots appear in the top left corner. Because of the paper is transparent, the dots below them remains visible as it can see through the transparent paper. Also notice that the dots can end up overlapping. In this case, the dots merge together and become a single dot. The second fold instruction is fold x5, which indicates this line. Because this vertical line folds left, the instructions are square. The transparent paper is pretty big, so for now focus on just completing the first fold. After the first fold in the example above, 17 dots are visible. Dots end up overlapping after the fold is completed count as a single dot. How many dots are visible after completing just the first fold of the transparent paper? Yeah, so let's save the puzzle input here again. 13. Let's see here. And I want to look into day 13 and see there's a lot of dots, and then we have a bunch of folding instructions down here. Okay. So let's start with our test data. fold along y7, 5, yeah, x5. So put this in here. And again, do we have a maximum of, nope, we have more than 1,000 positions here. But it looks like we have less than 1,500. So that might be a thing. Or we might be required to figure out how large the paper is as well, because here the last dots are at the end of the paper. So I guess that could be our first thing. First off, we need to figure out how large things should be. And in this case, we can also add all the folding instructions. So if line starts with fold along, then we will have a list of string folding instructions, new array list. And if this is the case, we want to take folding instructions, add line, substring, fold along, length, and trim that. So this means that we pretty much will remove the first part where it's folding along here. So substring will take everything after a set number of character. In this case, we say the number of characters should be the length of this string. So that's our first thing, and here we can continue. Else, we will take the line, trim it, split by that, and do string line array again. And that's a string array. And then we will have XY positions. So let's say that we have this int initial data, which is a new no, it only needs to be booleans actually, because it's only on off. And let's say that this is 1500 wide. And then for this line array, we want to take each of these int x equals in integer, parse int of this x value, and then we will take this to be the y value, and we can also have an int max x, int max y. So here, if max x is smaller than x, then max out. Let's do it more readable. Max x is equal to math max of x and math x. And do the same for max y. So there we go. And we also want to take our initial data No, we can't really do that. Because we need to know how wide it is. So, when this is done, we can take max x times max y. And then we will need to read these again. But as there isn't that many instructions, this should not take extremely long time. So initial data equals to max x times y plus x. And there we set it true. Erase, fill this with false. So there we go. So now we have done the first part here. We do another print out here just to see what we get. And again, it's good to actually run the right day. Day 13. Oh, we got a parsing issue here. 53. Okay. For input string empty. Okay, so if line is blank, continue. Let's skip those. Can we do that? Out of bounds exception. Okay. So let's go here first then and see what we got. 10 times 14. Okay. So actually need to have this one wider than the actual values. Yes. Like that. And then we get down there. So now we have two folding instructions, y7 and x5, and the initial data here. And it is 165 positions, I guess. And that's because we have 11 and 15. And larders up here are 10 and 14 then? Yeah. Seems right. And if we want to fold this, we could do this. We could have a function here. Public static void print map boolean map max x max y. No, just do max x. So boolean map, do an I integer here. We do an if max x I modulus max x, then system out print line, else do system out print, and if v is true, then we will output the hash mark, else we will output a dot. So that's it, and then we do a print up here as well, that we did in one of our earlier examples, and put in a little bit of line here, and then print line down here. So if we do print map here of the initial data, max x, what do we get? Yeah, so we need another print line here. But it looks like we have pretty much the same array here. So we have read everything in correctly. So that's good. Let's do the folding instruction. And if we want to fold on y something, then we want to start from the bottom up to y something, and we want to input that information, or we want to start on y plus 1 and then input that from the bottom up. So for we can take string fold equals to so we just do this for the first folding instruction. So folding instructions, get first one. If fold starts with y equals, and we do one thing, else we do another thing, fold y, we do that in the initial data, max x, max y. And then we can implement fold x later, but because we know it's a fold y, the first thing we do, then let's start with that. And we also want to have the y, fold y position, and here we will have fold x position, and int fold y position is equal to fold substring fold this y, I can just say 2 for simplicity, and then we want to integer parse int that, and down here we do the same for x position. Let's create that method. Are we clear so far? Are we good here? Do we have everything we need? Yeah, we have 7 and we have max and y and so on. So that's good. So then we want to have 4. We want to create a new boolean. Array of initial data. New data. And that should be arrays copy of range. Copy of initial data, and the new length should be max x times fold position y minus 1, right? So then we will remove that line as well. And then we want to make a for loop from y is equal to fold plus 1, y less than max, y plus plus, and then we do the same for int x. Max x plus plus. There we go. So, and new data, we want to take should we do it like this? 0 to fold plus minus 1. So here we want to take y plus fold plus y plus 1 times max x plus x. Let's see. Fold plus minus y times x. That's the new data position. And then initial data, we want to take, there's so much math here. Fold plus 1 plus y max x plus x. So we are still going row by row, but we are going in the one of the ones we are going down in the initial data from the y positions plus 1 going down, and then we are adding that to our new position here, new data. And so let's debug this a bit. More coffee. Or should we do like this? We can do it like this. Print map, new data, max x, and then print map, new data. So let's see here. We start this off, and we got outside of bounds. So let's remove that point there. Let's see if that's okay. Still outside of bounds. So full plus -1 then. Yeah, there we go. So we have created this -1 array size. So this has a size of 75 and 11 times 7 is 77. So 75. Isn't that a bit strange? Yeah. So let's see what we got here. We got 1 less than that. Yeah, okay. So that's what we want to do, of course. Yeah, so now we have 1 line there, which is not what we want. We want 2 lines, so we will do 2 fold position. And here we want to do -1. Let's see now. Now we got 2 lines there. That's the older one, we had 5 lines. And if we print that map, it should have added something to this line, which it didn't. So let's go back here. Didn't add anything to that line. That line got empty. So that's no good. If initial data is then true, else we keep the initial value here. Thank you. Just doing an OR there instead. So we want to do 2 of these. And here we should have added some values. If there is anything to add. There is a bunch of them to add. But it doesn't seem like we have done that. Do we need to do +1 here, perhaps? Just to be... Yeah, now we have started to add things here. So all of those are set. And down here, more a set. Yeah. So let's see if we continue this folding here. If we got the right folded structure. Yeah, we need to replace the initial data here. Boolean array. Like that. So now we have this kind of data. So in the top, we don't have the right. There we have the right. There we are right. There we are right. And that one is right. So I guess that we did one loop too few. So let's go all the way to folding position. And check out the result. Yeah. Now we have the last line correct as well. And then we need to count the number of dots visible. So let's do that. For initial data. Boolean dot. Int count. Count is equal to dot plus equal to and dot 1 or 0. And here we will take count and yeah, just print that out. Let's see what we get. We got 17. Great. I wonder how large this data set is. Is it? Yeah, it's pretty large. So let's do like this then. Yeah, so let's have the list string initial array new array list. So we will just put everything into this initial array here. Add line like that. And then we can take this initial array here and just do line 2 everywhere. So let's see if that works. Yeah. Not sure why I call it array, but number format exception for input string, way too much. What? Put the wrong input data again. 13. So let's see here. Run it again. Oh. We are printing large arrays. So let's not do that. when we're doing the non-test data. But 791 should be the value here for one fold. So let's try that. No, that's the right answer if you're stuck, you're using the full input data. There's also some great tips about the Evolve page. Okay. So that's curious. Is it that the first fold was of course an X. So we need to implement this as well. Of course. So let's create X and do the same as we did here, but for X. And I guess we need to do this. Get the second folding thing here. So this is the folding X position. So max Y times X folding position. We want to do that into max Y. And here we just want to do Y times max X X. So that's the new data. And here we will do again Y max X. And here we want to have folding position. Let's see, we go back to see what this actually said. So we remove that and we put it here instead. And then we will do the same for this and put it here instead. And do the same for the last part here. So that's a thing we want to have. And I now realize that we need to do both of the folds, because we can't really check it otherwise. So I will just do very crappy handling of this. Let's do both of them like this. And let's move back to our test data and run that. Yeah, let's do that. Here we have too much. So Y times folding position. Up here we had, or down here we had Y pos times X position. Mm. Oh, of course. Y times X position. Is it that or -1? It's probably -1. Yeah. Parentheses. So I wonder how large this actually is. Yeah, we need to update the max Y as well. And down here we need to update max X to folding position X. Does that help us? So here we have max Y of 7, max X of 11. And we are using max X on multiple places here. That's no good. There we go. Here we still need to use max X, because that's the large position. So yeah, we're actually able to do that. So we didn't update max X in the last point here. Let's add those, run again. So we got 18 after both. But we didn't really do a great job of folding it in our max X position here. So let's see what we did wrong. So this seems right. But this is totally wrong, of course. Let's see here. No, that seems pretty reasonable. So let's see here. Let's debug. So we have this one where we want to fold on this line here. And if we do that, then this thing here will end up here. So if we print that out, the first line should be filled in, and that's right. And then the next thing here, we should just keep those two, and they should not move as they do in this example here. So why do they move around? Can't just do a copy in the beginning here, of course. New boolean, new data equals new boolean, and then just create this array. Then we will do a for loop. Yeah, let's do these two for loops just for ease of it. Then new data is equal to initial data, and here we have y times folding posts plus x, and here we have y times max x plus x. So that's pretty much it. If we print both maps up here, we should get a better starting position. Yes. Which means that we should have nope. Didn't solve it. But at least we got closer. So, first one, we solved that. Second one, we didn't do any change. Third one, we added a bunch of things in the wrong position. Why did we do that? Where did they come from? Y times x position. So start off here, and then we don't even get the right. So that's the correct thing. And this needs to be that. I wonder if we do like this. Yeah. So we just comment these lines out. And I want to do the opposite here. I just want to copy this full array over to this data here. What do we get? So we get this kind of a thing. And if we keep that down here, and then go up and see if that is even closely equal to this part over here, which is, it is not. So this is moved a bit. So why is that? It's like we have one too much of something. Okay, let's do this. And see if we get a straight line on the left-hand side. We don't. Why not? Let's print the first one here. So here we have this kind of thing. So now we should have had one left side here with all the positions. Yeah, let's print it out down here. Let's do that. So if we go one more, all of these positions should have been filled, but they aren't just right now. And if we do that, then x should be 0, so we should fill let's do array fill new data with false. Let's do that. So we empty it out down here, and then we will print. What do we get? Not even close, not even close. So if we go back to field, to that, what do we get then? Then we get a straight line there. If we do like this, do we get a straight line on the other side? We do. So do like this then. Yeah, then we have mirrored that. And if we do the same here, focus, move that, and we have the right thing there, focus, mirror that, make it a little bit more readable. Replace two, so yeah. Oh. Don't do that then. Let's see. Oh, I kept this one. Oh, that's not right. Let's do this. Yes, we got the square. Let's do less printing here. So we have our square. Then we will remove this thing. And just do the first folding exercise here. Change our input data. Of course we get out of bounds exception. Why not? I think we need to figure out if this is an uneven number of things, because the actual values need to be uneven in order to even split them. So that might be our issue here. If we have any even values, yeah, max x is an even number, which is not good, not good at all. So if max x not equal to 0, then max x plus plus. We can do max x plus equals to 1, 0. Like that. And do the same for max y. If we do that, we should have an uneven number here, yes. So we need to keep that in mind every time we do these kind of things, or else we will have a crash on our hands. Still have an out of bounds exception. So what do we get here then? Let's do the calculator. 655 times 2 is larger than the value we want. Yeah, so they want to do this in a space that is larger than the actual value that we can. So what we want to do here is actually max x minus fold position. So we want to take what we have left on that side and run that. Is it still minus 1 or something like that? So that seems like we can do. So I wonder if this is the same for the other value that we had here. Max y minus that minus 1. Just to be sure that we can have the same for both folding situations. And so let's go back to our initial data again. So that was 17 dots. How many dots did we have here after the first fold? Should be 17. Yeah, it seems reasonable. So let's stop printing this map and let's try this 675. See if that's correct. Yes! You get a gold star. I get a gold star. Everybody gets a gold star. Yes. Finish folding the transparent paper according to the instruction the manual says. The code is always 8 capital letters. What code do they activate the infrared terminal imaging camera system? So we needed our print out here after all the folding is done. So let's go back to our example here, and that should give us a 0 if we do that correctly. So we have our folding here, so for string folding instructions. Let's do that and run that. Then we got a 0. So let's do this with a full set of data and hope that it doesn't crash anywhere on the way. And it does. Darn. Yeah, because we haven't changed the initial data size, of course. So, can we go back and remove this thing here and have it with without this extra. Is that a thing we can do? Oh, we got something out. H, let's see, H, Z, K, H, F, E, J, Z. That must be it. That must be it. Come on, come on, come on. Let's do it. Yeah, you get a gold star. I get a gold star. Everybody gets a gold star. So the part where I thought that I needed to change the array and number of folding actions weren't really true. So the only thing I needed to have is actually a thing where I didn't go to the full max, because the max x is always the one that is telling us how much space we have. So I needed to just take max x minus folding position x minus 1. So let's look into this a bit here. What did we do? So first off, we had a lot of testing data here and some folding positions where we wanted to fold along. And we had a similar thing that we usually have, where we can read from a file, and then we read in the folding instructions. And I also have an array here where I will put everything that I've read from the file, so I don't need to read the file again. And then we go through each line, we skip the blank lines, we pick up the folding along, which is the folding instructions, and put them into an array here, substringing the first folding along, so we only have the actual things that we want to fold. And then I will take the rest of the positions and take the x value and the y value, put that into a little bit. I put that's into a line array, and I also calculate the max value of x and y, so I know how large the space is that we want to fold. And then I create an initial array and fill that with the false. And then we will fill that array with the x and y positions and just set Boolean values true where it actually is true. And then we will go through each folding instructions, and if it starts with a y, then we will fold with a fold in y direction, and if it starts with an x, we will fold in the x direction. So we will pick out the actual folding instruction here, so the folding position, put there. After that, the folding position will be the max y and the max x, so we will update those on each folding round. The folding is pretty much very similar to each other. We create a new data, we do a copy of that data. In this case, we do the copy with array copy, because the x value, which is the columns, haven't changed, so that there we just remove a bunch of lines. Up here, we actually need to do a copy, or else we will not have the correct data. So we will do a for loop and copy the values manually. And then after that, we just go through and read from the middle, for instance, and then go out. So the positions in the middle will be written to the other side and vice versa. And there were a lot of maths and trial and error in order to get that right. But we had this print map function down here that helped us out, and we can print the actual map and see where we were with our data. I hope that you found this interesting. I hope that you learned something today. We have actually passed the middle part. We have done more than half of the puzzles in Advent of Code, which is really exciting. I hope that you liked this video. Give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that, and you will see more puzzles like this. If you have any comments or suggestions, leave them in the comment section down below. Or if you have solved this differently, I would like to hear about your solution, so I might learn something as well. Thank you for watching, and I really hope to see you in the next video.